When you reach the end of your life, what will you do? The only thing you can do is leave something behind, to entrust your will to those who are still living. Then, when the end comes for all of us, when human civilization itself faces extinction, what will we do? We would likely attempt to pass on our will, to extraterrestrial beings yet to be encountered, to machines of our own creation, or to civilizations that may one day emerge in the future history of the universe. Then what about when the universe itself approaches its end? Physics suggests that the universe has an inevitable conclusion. When the end of all things draws near, what actions might the intelligent civilizations of the future universe take? Here's what I think. They would likely do the same, give birth to new universes, and attempt to entrust their will to the new beings that might one day arise there. According to inflationary theory, the possibility of artificially generating a new universe, essentially a technology capable of triggering the next Big Bang, is not ruled out by the laws of physics. And when facing the end of this universe, such an endeavor will carry profound significance. In this way, information might continue to be passed on, across generations of people, generations of civilizations, and even across generations of universes. And if such a future is possible, then looking in the opposite direction, into the past. This possibility may suggest that our own universe is also almost certainly the result of the same process. Even if the probability is small. It makes the likelihood that this universe was intentionally created by a super civilization in a previous universe greater than the likelihood that it arose spontaneously from nothing. If that's the case, if that's truly what happened, then where is the will they left behind? Where is the message passed down from them? I think it may be embedded in the very laws of physics of this universe. The reasons for this are as follows. The laws of physics are universal and eternal across all space and throughout all epochs in this universe, making them the ideal medium for preserving information. They could be an excellent paper for writing messages. No matter what language, mathematics, or system of thought any civilization possesses, as that civilization's understanding of physics advances to the point where they can fully comprehend the laws of physics, the information inscribed within them would also inevitably be readable. Thus, they could become the ultimate universal language. Even setting aside these benefits for the recipient, from the writer's perspective, the places where such information can be inscribed are inherently limited. This is because, as will be discussed later, any informational connection between a previous universe and a newly born one is confined to the moment of the Big Bang and the briefest instant immediately afterward. So, the trace, if any, would most likely be found within the fundamental structure of the universe, the laws of physics, the only information that existed at that moment. For example, by uncovering what we now refer to as a grand unified theory and deciphering its equations, we might discover a message encoded within it. Of course, the existence of such a message, the will of a civilization from a previous universe entrusted to us, is not something supported by scientific evidence. It's just my own imagination yet. However, there are logical foundations that support this possibility. And I can even predict the general content of that message. Let me now explain in more detail. When you die, your being returns to nothing. Your journey ends there, and most likely, nothing lies beyond. Does that mean life has no meaning? Our emotions, our brains, our instincts, our cultures, they all resist that conclusion. Even if your own existence is destined to vanish, you will still seek, at the very least, to prevent the fact that you lived from being lost entirely. And we do this by entrusting our will to the future. The genes passed on to your children. The knowledge or skills you gave your students. The works and creations you leave behind. The small change you made in someone's life. In any form, these traces of you may outlast your death. They are proof that you were here. And through letters, genes, memories, influence. Whatever the medium, these are all forms of information you engraved, and they can be messages carrying your will forward into the future. In this way, you can extend your story beyond death. And through that continuation, give meaning to your time alive. While the expression may differ, the underlying idea is universal, a way of thinking shared across time and culture. There is meaning in the fact that, even after your death, those causally connected to you remain alive. As long as someone exists who has inherited information from you, your will does not vanish completely, it lives on in the world through them. Of course, they too may one day die. But just as you did, they will entrust their will to those who follow. It is through this ongoing pattern, across generations and through countless intertwinings between individuals, that humanity as a whole has woven a continuous fabric. This is what we call civilization. Seen from a broader perspective, the history of humanity is a single, vast current of information that has ultimately flowed into us. We, too, are but a moment within this ongoing stream that will continue into the future. You are a single mesh point in the great fabric woven by the connections of information. Even if all the material things you left behind decay. Even if no one remembers your very existence. As long as someone remains alive at the end of the chain of connection, this fabric will endure. And your will, as one thread within it, will continue to be woven into the future. Let's leave the sentimental poetry behind. What I want to say is that this value lies at the foundation of who we are. And it is an important logic that gives meaning to our lives. Here, what becomes essential is the existence of a receiver. If you are destined to die, and if at the moment of your death the entire world disappears along with you, could you truly find meaning in your actions before death? Regarding the act of entrusting one's will, even if, as previously explained, we interpret it in the broadest possible sense, allowing it to be established through even the slightest connection of information, the essence still lies in connection, and therefore, a receiver for the message is always necessary. If no one remains in the future, if what awaits is only nothingness or the random motion of particles, then there would be no meaning in entrusting. Without a receiver in the future, the fabric of civilization would lose its connections, all our will would be severed there. And the very fact of our having lived would vanish entirely. Even if we place the meaning of our fleeting lives on something greater that continues longer than ourselves, if that too is destined to end someday, then in the end, everything would become meaningless. Thus, humanity will seek to avoid such an end. If no receiver can be found among ourselves, we will search for a new one, and if necessary, create one with our own hands. All for the sake of continuing the woven chain of will into the future, giving our lives meaning. When humanity one day faces inevitable extinction, be it through the expansion of the sun, the collision of galaxies, or some other inescapable fate, civilization will do exactly what the individual does when approaching the end of their own lifespan. As a testament, we may leave behind constructs that continue to emit message signals, expanding outward into the cosmos long after our death. As a legacy, we may release monuments like messages in a bottle, filled with all the knowledge humanity has accumulated, mathematics, physics, culture, our DNA. The receiver, in this case, would not be anyone among us. It would be directed toward unknown beings who may exist somewhere in the universe, or toward the life forms that will emerge across the vast future of space and time. If this civilization is to end, then we entrust its will to another civilization. We might preserve all useful data, such as the entire archive of the internet, within data storing satellites, left adrift like monoliths in the cosmos, waiting to be discovered across eternity. Or we may actively seek out receivers by launching self-replicating bots that journey across stars and galaxies. Or, depending on future ideologies, we may no longer feel that receivers must be living beings. We may come to entrust our will to machines themselves. In whatever form it takes, these are acts of continuing connection beyond our own disappearance. Just as an individual life is fleeting, so too might this civilization be no more than a brief and fragile moment in the vast scale of the universe. Yet, to entrust our will to what lies ahead is to affirm that this moment truly happened. To mark our existence upon the world, and to declare that it held meaning. Up to this point, we have spoken of scales ranging from the individual to the entirety of human civilization. And so far, these ideas remain within the realm of familiar, often discussed generalities. Many concepts have already been proposed for preserving the knowledge of civilization as a legacy. And in all likelihood, such efforts will indeed be undertaken in the near future as a way to prepare for our extinction. What I wish to explore in this video is what lies beyond that. The possibility that the very same pattern may emerge again, on an even greater scale. So next, let us turn our gaze to the scale of the universe itself, taken as a whole. First of all, this tendency to entrust one's will is likely a universal trait found in all civilizations throughout the cosmos. In other words, it is not a coincidental feature unique to human society, but rather a natural outcome, perhaps even an inevitable one, that emerges alongside the development of intelligence. This is because our desire to seek some continuity in the world beyond our own death is deeply rooted in the logic of evolution itself. Our brains were shaped by the algorithms of evolution. And in that process, it is not the individual's life or death that is prioritized, but rather the preservation and transmission of one's own program code. In the case of life on Earth, this program takes the form of genes, encoded in sequences of DNA. On other planets, the chemical structure may be entirely different. But the nature of the physical medium does not matter. What is essential is the information stored within it. Even if the individual dies, the transmission of their genetic information to future generations is registered by the evolutionary algorithm as a success, a valuable outcome. And this forms the basis of our present-day values, impulses, and desires, the drive to entrust something of ourselves to others, even to other civilizations. It is, in fact, a deeply ingrained sense, one that may be as fundamental as the instinct for survival itself. And whether the object is a sequence of genetic code, an arrangement of language, or any other form, it is all the same to the impulse. All of these are forms of information, messages that carry our will. To pass on the information we possess, to leave behind a trace that we lived, becomes a purpose in itself. And this trait may well be shared by intelligences born independently on distant worlds, entirely unlike our own. As long as their emergence is rooted in the logic of evolution, they too may possess the same drive. Just as having the instinct for survival can be seen as an inevitable feature of life, so too might this impulse to continue one's information beyond death be considered an inevitable trait of living beings. And by extension, of the civilizations their intelligence gives rise to. Additionally, this trait may not be limited to the side of the brain, it is also likely to be inevitably present on the informational side shaped by civilizations. The information that is to be entrusted may have a tendency to exert an influence on intelligent beings, prompting them to leave it behind. Ideologies and value systems that shape civilizations, informations that spread across generations over long periods of time, are subject to the same evolutionary principles as genes, replication, variation, and selection. As a result, they will inevitably evolve into forms of information that are stronger, more resilient, and more capable of propagation. The religions, political ideologies, belief systems, and worldviews that flourish around us today are precisely those that possess such traits. Forms of information that subtly compel us to spread them, preserve them, and pass them down across generations. What remains now are those that have demonstrated this power. And this very force may, by the same mechanism, compel us to leave behind them even beyond the extinction of our species. This is not only about our own society. It is likely an inescapable trait of ideas, one that inevitably accompanies all cultures, regardless of the civilization that gives rise to them. Intelligent beings may be compelled from both sides, by the inward force of the brain and the outward force of the message itself, to entrust their will. And at their core, these two forces are the same. In an extreme sense, if there is no other path for design to emerge in the universe except through the logic of evolution, then entrusting becomes an essential element, an intrinsic feature that inevitably accompanies all forms of design. Next, the appearance of life itself is likely not unique to us, but rather a universal phenomenon throughout the cosmos. Recent advances in biochemistry suggest that it arises through far more natural processes than previously believed, now thought to be a common occurrence that may happen many times across the universe. On any planet with suitable conditions, like Earth, the sequence of events from the emergence of self-replicating molecules, to the development of intelligence through evolution, to the formation of groups, and eventually the rise of civilization, can be considered highly plausible. Even if the probability of this occurring at any specific place and time is extremely low, when viewed against the vast denominator of the entire universe, it would still result in countless civilizations emerging throughout cosmic history. If the emergence of civilizations, and their tendency to entrust their will, is indeed a universal and commonplace phenomenon, then the same pattern that applies to each of us should also unfold at the level of civilizations. A continuous flow arises, in which each seeks to pass something on to another before it fades. And just as humanity, through countless chains of entrusting, has woven the fabric of its own civilization here on Earth over the course of its history, so too should civilizations across the universe come to weave a higher order fabric over cosmic history, that of a cosmic civilization. However, when I speak of something as commonplace, I mean it in terms of the scales of cosmic space and time. From our perspective, connections between civilizations remain extraordinarily improbable events. The primary reason for this lies in the limitation imposed by the speed of light over the vast distances in between. Even if we were to send a message at light speed to a neighboring galaxy, it would take 2 million years to arrive, and just as long for any reply to return. Actually traveling there would take even longer. Moreover, compared to such immense timescales, the lifespan of a civilization capable of communication is likely to be brief. Thus, since it is unlikely for two civilizations to exist simultaneously in nearby regions within the same galaxy, direct encounters between civilizations are unlikely ever to occur. Civilizations may be more like flickers, brief appearances that emerge and vanish in distant corners of space. Accordingly, connections between civilizations are unlikely to occur through direct handover. Instead, They would take the form of messages left behind, like letters placed in advance, passed on across billions of years, long after the originating civilization has perished. But even this span of time is vanishingly brief when seen against the lifespan of the universe. Across cosmic time, countless such passings on may occur, generation after generation of civilizations, just as we have done throughout our own history on Earth. And the paths of those connections would likely follow similar patterns. Some civilizations may disappear before passing on the knowledge they received. Some legacies may be left behind only to decay, unnoticed and unrecovered. Yet in other cases, a single message may be received by multiple civilizations, causing the flow of connection to branch. So, this chain would not be a single thread, but would instead form a vast fabric, woven through diverse civilizations scattered across space, interlacing in complex ways over time. Here, the scale of that fabric would be the entire universe, spanning all of its space and the full course of time from its beginning to its end. And the longer this universe-spanning fabric continues to be woven without interruption, the more technological advancement each civilization will gain, built upon the accumulated knowledge passed down from those that came before. And the more advanced a civilization's technology becomes, the more reliably it can entrust its will, leaving behind greater legacies, preserved over longer periods, and passed on through more dependable means. Over time, the overall level of civilizations across the universe would continue to advance. The scientific and technological power of later civilizations would be far beyond comparison with our own single instance of civilization. With a complete understanding of the laws of physics and intelligence and capability on a cosmic scale, it would be able to realize anything that physical law allows, perhaps even the creation of new universes. It would no longer be vulnerable to minor catastrophes on the scale of stars or galaxies, and contact with other civilizations would become far easier. The mesh of the fabric would extend across all civilizations, becoming increasingly integrated, and ultimately form a single, enduring, and immense super-civilization spanning the universe. So far, we have spoken of a progression from Earth to a cosmic scale. Up to this point, the future can be predicted with relative ease. Even if the specific path may vary, a convergence toward the emergence of a universe-spanning super-civilization is highly plausible. What I aim to explore in this video lies beyond that, beyond the cosmic scale, on a level even higher. When you reach the end of your life, you may leave something behind, to entrust your will to those who are still living. They, in turn, may entrust their will to others in the future. And in this human chain, your will continues on. When human civilization comes to an end, that will may be entrusted to another civilization somewhere in the universe. That civilization, too, may one day pass its will on to yet another. The chain of civilizations will be woven throughout the history of the universe. And all of it is connected, from you, to the very end of the cosmos. The will you entrusted will continue on through this chain of entrustment, carried forward across the entire universe. The effects of your existence will extend across all of space and time. The fact that you lived will be recorded as part of the universe's history. The trace of your life will be inscribed into the cosmos. Of course, this is only if fortune allows. The thread of connection that begins with you may be cut off at any point along the way. But what matters is that the possibility is not zero. Because there is a chance that the thread will continue without end, you can allow your own story to carry on, beyond your death, and even further. That is why what you do while you are alive is not meaningless. The event that you were born, that you live, and that you entrust something to others, all of it can hold significance. However, in the end, the universe itself also has a finite lifespan. There are several possible scenarios for how it might end, such as accelerated expansion or a reversal into collapse. But the most physically well-defined, inevitable, and utterly inescapable outcome, even in the face of any conceivable force, is heat death. According to the second law of thermodynamics, the entropy of the universe will continue to increase, and its future is destined to fall into a state of total chaos. In that state, there will be no life, no thought, no design, no meaningful information of any kind. Everyone will be gone. All messages will vanish. No trace will remain. Only random fluctuations will persist. This is a clear and predetermined end, set in motion from the very beginning. From the moment it came into existence, the universe has been steadily heading toward its death, an existence bound for an end, just like us. It may seem like a concern for the distant future, but it is something that matters deeply even to us now. If the world, and all that we entrust, is certain to disappear, if there is absolutely no possibility other than that outcome, then does it matter what is drawn on the canvas, if in the end it is guaranteed to return to pure white, or perhaps be covered entirely in black? If the universe itself is nothing more than a transient phenomenon, destined to end, then the same question we ask of individual lives must also be asked of the universe as a whole. If there is an end, does that make everything leading up to it, all civilizations, all forms of intelligence, including us, ultimately meaningless? This is a question that all intelligence in the universe will inevitably face. It matters to everyone, in every time and every place. What I predict here is this. Just as it occurs in individuals and in civilizations as they face their own end, the very same pattern may emerge again, this time, in relation to the universe itself. When a future super civilization comes face to face with the end of this universe, it will likely do the same thing you would do at the end of your life. Entrust its will, the will of all the intelligences that ever lived in this universe, to the next universe. To that end, it will create a new universe and leave behind a message. The receiver, in this case, would not be anyone among anyone in this universe, but rather a new being who may one day emerge in that new universe. What is done remains the same. All of it is an act of continuing connection beyond own disappearance. To entrust the will to what lies ahead, is to affirm that this universe truly happened. To mark our existence upon the world, and to declare that it held meaning. Let us begin with how to create a new universe. There are several variations of theories that suggest the emergence of multiple universes. However, a simulated universe would not suffice, no matter how advanced it may be, if it ends together with this universe, where the simulator itself resides. It cannot serve as a receiver's world. And even with other types of universes, the next one must be a universe in which entropy is reset. If it shares the same lifespan as the current one, it cannot fulfill the purpose. What's needed is not merely increasing the number, like cell division, but something more akin to the birth of a new child. So, the most fitting approach is also the simplest and most direct one, to physically recreate the very same event that marked the beginning of this universe. In other words, to trigger a new Big Bang. A future super civilization would likely aim to initiate the birth of a new universe, to create the seed of next Big Bang. The further back we trace time in this universe, the smaller it becomes. It is said to have begun from a single, extremely small point, a tiny volume from which it explosively expanded and eventually became the universe filled with matter that we observe today. According to classical Big Bang theory, triggering the next Big Bang was considered impossible. The theory assumed that if one wanted a universe of the same scale as ours, an equivalent amount of material would be needed from the very beginning. One would have to gather all the mass and energy of this universe, compress it to an unimaginable density, and somehow ignite it in an outward explosion. Clearly, such a task lies beyond the capabilities of any technology within this universe. However, classical Big Bang theory has since given way to a more refined model, the theory of inflation, which posits that the universe expanded exponentially. This theory, now widely accepted, shows that an enormous amount of matter can spontaneously emerge from a tiny seed, and that the outward expansion is automatically driven by negative pressure. It is now believed that our universe began in this way. Compared to the classical model, this theory makes the conditions for initiating a new universe vastly more feasible. All we would need to do is prepare the initial seed, composed of only a small amount of material. Once that is in place, the seed will grow on its own. It will spontaneously drive its own expansion, rapidly generating vast space and drawing enough energy from gravity to form all the matter we observe. In this way, the next universe would be born. The only material required to create such a seed is about 10 grams of the inflaton field. The challenge lies in the fact that this seed must be compressed into a lump just about 10-6 centimeters in diameter. This is far beyond the reach of current human science, but it is merely a technological hurdle. With the technology of a future super civilization, one born from the long chain of accumulated progress, it should eventually become possible, sometime within the lifespan of the universe. Additionally, if we accept the condition that it doesn't matter what happens to this universe in the process, that it may end at the moment the new universe is born, then the range of possible methods greatly expands. If the purpose is not to meet but to entrust, then both universes do not need to coexist. Moreover, even setting that aside, it is certain that no meeting will ever occur. In principle, once the seed begins to grow, that is, once the newly forming space starts to expand, it is, in that very instant, pushed out of our side by the pressure difference and severed from this universe. It becomes a completely separate and independent region of space, fully detached from its parent. From our side, it would appear as though the space at that location had collapsed inward and the seed had vanished. To us, the entire process would look no different from the formation of a black hole. We cannot see inside a black hole, and there would no longer be any connection in spacetime between the two sides. the newly created universe would lie beyond all possible access, outside this universe entirely. After the birth of our universe's child, and once the umbilical connection is severed during that brief initial moment, there will no longer be any way to see or meet it again. From the perspective of this universe, the act yields no gain, only a black hole remains. Nothing returns from the other side, not even the slightest bit of information, not even confirmation that the attempt succeeded. There is no reward. It is a one-way offering, a gift given without return. And yet, just as life does for its offspring, the final civilization of this universe will likely do the same. Because in doing so, it can pass on information to the next, entrust our will to what lies ahead. The specific scientific theories discussed so far remain within the realm of speculation. Our science is still in its infancy, and as long as the fundamental laws of this universe remain only partially understood, the details of how to create a new universe cannot be known with certainty. In addition, we cannot possibly know what might be achievable for a future super-civilization possessing intelligence and technology far beyond our own. However, even if we cannot foresee the specifics of future science, there is much that can be logically predicted. From here, we will explore what kind of universe might be created, where a message might be placed, and what its contents could be. To begin with the nature of new universe that would one day be created. We can likely infer what it would be like simply by looking at our own. Even setting aside everything discussed so far, the idea that our universe might be a designer universe is a well-known and often explored possibility. Take, for instance, the fine-tuning of physical constants. If the masses of fundamental particles or the values of other constants differed even slightly, the universe would have either ended quickly or never reached a state suitable for life to emerge. Our universe appears remarkably well adjusted, not only long-lived but also hospitable to intelligence. Moreover, even if we assume that the universe began with the Big Bang, we must still ask, why was there an initial seed at all? Given that the probability of such a thing arising spontaneously from nothing is vanishingly small. If there is even a slim chance that intelligent beings like us could create a universe, then statistically speaking, it is far more likely that some universe was created than that it arose from nothing. And as discussed up to this point, if the act of entrusting, passing on information, is a universal trait that emerges with the appearance of life, and if a civilization from this universe will one day create the next, then it becomes far more probable that this universe, too, was a gift from a predecessor in the same way. This may be part of a recurring, chain-like pattern occurring between universes. A process that unfolds on a scale beyond any single cosmos. In that case, our universe would not be the first domino at the head of the line, but rather one that was triggered by a predecessor. If that is the case, if our universe was indeed something given to us, then a certain question arises. Why does it have a finite lifespan? Why not a universe with no end at all, instead of one that is merely relatively long-lived? Why is there a law of increasing entropy? And what about other physical constraints that seem to limit us, like the speed of light? Why do such rules exist in the first place? This appears to be a problem of logic. Unlike a simulated universe, such as those in games, a physically real universe cannot be made completely freely. Its very reality imposes constraints, rules that must necessarily be followed. First and foremost, the essential condition for any reality to exist is logical consistency. This is the most fundamental constraint. Anything containing contradictions cannot exist, nor can it be created. For example, if the speed of light could be exceeded in this universe, it would result in time reversal, inevitably leading to violations of causality, paradoxes such as the grandfather paradox. A universe identical to ours in every respect except lacking the speed of light limit would face such paradoxes that its very structure would collapse. A universe containing internal contradictions of this kind could never have come into existence in the first place. Therefore, even if a creator had the freedom to define physical laws arbitrarily, they would still be required to design them in a way that guarantees no contradictions could ever arise from any possible future within that universe. A program that leads to bugs cannot function as reality from the outset. Second, any universe that is to be created must be one that can be created. Specifically, it must be a universe with a clear beginning, something like a Big Bang. A steady-state universe with neither beginning nor end, or one that loops endlessly in a closed cycle, or one that stretches infinitely into the past, would not be acceptable. Such universes contradict the causality of being created and therefore cannot be brought into existence by others. A universe that is to be created must, by necessity, have a past of being created. Even if one had complete freedom in its design, the temporal structure must still include a definite starting point. Likewise, in terms of space, the origin must be of finite size, since it is not possible to prepare a seed larger than this universe. Thus, from the Creator's perspective, it is preferable that the universe, when traced backward in time, begins from a single point composed of a small amount of initial material, just like ours. At this point, the increase of entropy seems unavoidable. The second law of thermodynamics is less a rule of physics and more a consequence of pure logic. Unlike other physical laws, it is not a programmed formula but rather a natural outcome that arises from the nature of probability. Because of this, it is unlikely that entropy can be removed without contradiction while still satisfying the aforementioned conditions. What matters here is that entropy defines an absolute directionality in the flow of time. As long as this one-way flow exists, even if we were to reverse it, setting entropy to decrease over time, it would simply invert the beginning and end. The universe would still have an end, only the direction is swapped. Moreover, we likely cannot eliminate the very concept of time itself. The causal relationship, that the new universe is born from this one, necessarily gives it a one-directional structure. Since there must be an event that marks a beginning on one side of the time axis, a direction in the flow of time becomes unavoidable. The very asymmetry of having originated from a prior universe makes it impossible for all concepts to remain symmetrical. As a result, some directional concept must be embedded in the system. That directional concept will be treated as time in that universe, and some quantity, like entropy in this universe, will define its direction. As that quantity progresses in one direction, approaching either infinity or zero, the universe will age and eventually come to an end. As if following the adage, what has a beginning must have an end. One may be able to construct a river, but not a perfectly closed, self-contained sphere. At the root of these constraints is the very fact that that new universe is being created from this one. Any newly born universe will inevitably be limited by the causal connection to ours. Third, intelligence must emerge. If the purpose is to create receivers for the message entrusted from this universe, then the natural flow dictated by physical laws must lead, through an algorithm like evolution, to the emergence of life, or something akin to intelligence. Moreover, these beings must have the potential to form an advanced civilization capable of creating the next universe. To make this possible, the universe must be finely tuned to conditions that are as suitable for them as possible, just as ours appears to be. Fourth, the universe must be one that allows for the creation of another. For example, if this universe had followed the classical Big Bang model as it was once conceived, the path to creating a new universe would have been closed. Likewise, if it had been built more simply, lacking quantum mechanics, relying only on Newtonian physics or relativity, it likely would not have allowed for the possibility either. Such a universe may not have been created at all. If the Creator's goal is to continue a chain of their will, then rather than designing a universe with a fixed lifespan and no possibility of producing next, one in which the chain is destined to end, it would be more fitting to create, as life does, one that gives rise to offspring capable of producing offspring themselves. If we are to design a new universe, we must program its physical laws in a way that allows another universe to be created without contradiction. The simplest way to guarantee that is to replicate this universe. If a universe succeeds in creating another identical to itself, then by that very logic, the next universe must also have the same capacity. If this universe can produce a copy of itself, then that very fact guarantees that the next one must also be capable of producing another, and so the chain continues. In such a scenario, just as it does in self-replicating life, evolution might begin to operate at the scale of universes themselves. As we'll discuss later, this would naturally favor universes that can produce more offspring more reliably and from fewer resources. At this point, the entire process would continue entirely automatically, without any assistance from the original creator. Therefore, if we wish for the fabric of connection to persist across generations of universes, then it is preferable to create a universe capable of self-replication, not just for the next generation, but with a long-term view far into the future. Fifth, we have seen many constraints imposed by logic, but then, is it possible to change that logic itself? Could we create a universe that follows a logic entirely different from our own? Or even one that is free from the very framework of logic altogether? In this universe, we cannot act against this logic, but could we, in its successor, create a universe free from the logical constraints we are bound by, such as consistency or causality? Most likely not. We probably cannot create a truly new universe from scratch. A universe that emerged spontaneously from nothing, without any involvement from our own, might indeed follow a completely different logical system, because it would be entirely independent of us. However, as long as the universe is created from this one, it will almost certainly inherit the same logical framework. This is because the two universes, ours and the next, are connected at the level of logic. Even if they soon become separated in space-time, they remain informationally linked at the point of origin. They cannot be logically independent bubbles because of the connection. We can entrust our will only because there is an informational connection, but precisely because such a connection exists, we cannot escape this framework of logic. What is born from this universe cannot become something fundamentally different at its core, not the next universe, nor the one after that. If, on a scale beyond individual universes, a chain of universe creation and the entrusting of will is taking place, then all of them must be following the same logical framework, because they are all connected. This logical structure has never changed, not from the beginning until now. The logical system we follow today originates from what was imposed on the very first universe. In other words, if we trace back every limitation to its source, they all ultimately stem from the very first, spontaneously emerged ancestral universe. Even if the surface-level programs can be rewritten, no universe can escape the underlying framework of logic itself. In this way, we see that the next universe will not be truly free, there are conditions it must fulfill. As a conclusion so far, it is likely that we will end up creating a universe very similar to our own, even if we had complete freedom to design its physical laws. This universe satisfies all the necessary conditions listed above, and it is simply too well constructed. Thus, we would likely create a similar one, either identical or slightly improved and fine-tuned. This universe has given rise to life, allowed civilizations to develop, holds the potential to create new universes, has a long lifespan, has a history of beginning from a seed, and is internally free from contradiction. This universe might not be only a gift from our predecessors, but also an inheritance passed down through countless generations before them. The crystallization of many iterations of refinement. The reason for creating a new universe is to seek out a receiver, an intelligence inheriting the will beyond the end of this one. Then how, exactly, is that will to be entrusted? How is the message to be delivered to such a receiver? In other words, if a hyper-civilization from the previous universe created this one, where in this universe would their message be? Such a message has yet to be found. Why has it not reached us? This connects to the constraints we've discussed so far. The methods by which a message can be delivered are severely limited. Once the new universe begins to expand, it is separated, after only a brief moment, into a completely distinct region of space-time. Even if the predecessor civilization were still alive now, they would no longer be able to send any information into this universe. Therefore, if any message is to be written, it must be done at the time of the seed's creation, or during the brief moment just after the universe begins. Nothing arising after that separation can serve as the vehicle. Thus, the message must be embedded in something fundamental that already exists from the very beginning. The most fitting candidate for that is the foundational program code of the universe itself, that is, the physical laws. If this universe were a simpler one, there likely would have been no place to write anything there. Had it consisted solely of Newtonian mechanics or general relativity, the program would have been too minimal, leaving no spare capacity for additional information, and any such attempt to insert it would have drastically altered the universe itself. This universe is simple in everyday domains, everything can be calculated from just a few equations. But once we step outside that domain, physics become increasingly, even bizarrely, complex. It is said that this universe is built upon two sets of game rules. On the macroscopic scale, it follows general relativity, on the microscopic scale, quantum mechanics governs. In everyday situations, we rarely need both at once, so we can use physics without issue. However, if we try to unify these two sets of rules, the result becomes too complex for our current civilization to compute, so much so that even describing it would require 11 dimensions. This unified condition is precisely what arises in black holes and at the moment of the Big Bang. It represents the physical environment at the very beginning of the universe, its original state. This is likely where the highest possibility lies. A unified theory that merges the two, such as the well-known string theory, has sufficient informational depth. And because it would be the very law that governed the universe at the time of its creation, any data embedded in that moment would be written into it. When we finally uncover that theory, we might find the message encoded within it. In this case, the very act of tracing the universe's origins, looking backward through time, becomes the path to discovering the parent's information. Why is the message hidden in such an obscure place? In addition to the limitations on where such a message can be written, it may be hidden simply because it must be. Suppose a message were to appear boldly in front of us, then that visibility would have had to be deliberately built into the laws of physics from the beginning. But modifying physical laws in that way would surely distort the universe in obvious and significant ways. a message must not be embedded in a way that affects the ordinary, everyday scale. Such interference would disrupt the finely tuned balance of the universe, designed, as we discussed earlier, to be optimal for intelligence. The message should not alter the domain in which life exists. Therefore, it may only be natural that we cannot see it in our daily experience. Besides the Big Bang and black holes, another potential candidate is transparent particles. The kind often invoked in fantasy to explain mysterious powers, unknown particles with no charge, no mass, and no interaction with ordinary matter. Scientifically, such transparent particles can be freely hypothesized, because their existence wouldn't contradict what we observe in the universe. Any number of them could exist in this universe, and adding them would not interfere with other physical laws. In daily life, they would be no different from non-existent, but just as superconductors affect photons. If these particles are set to act only under certain special conditions, then, like a fantasy author, the creator of the universe could embed as much added information as desired, without changing the universe as we know it. There is, therefore, a real possibility that such extra particles were added to this universe for the sole purpose of conveying a message. Likewise, it is also possible that entirely unnecessary and meaningless equations have been intentionally added to the physical laws themselves. For example, imagine a set of laws governing a scale even smaller than quantum mechanics, or another set that becomes dominant at scales beyond general relativity. It's conceivable that messages could be embedded within such equations. Even if these laws were indeed included in the universe's design, they would lie outside the range of scales we perceive, so regardless of whether they exist, or what form they take, they would make no difference to the functioning of the observable universe. To put it another way, it would be like deliberately adding garbage code that never actually runs, to the program of the universe. No matter how much information or language is embedded in it, the result of running the program remains unaffected. There might be physical laws that have never influenced the universe at any point since the Big Bang. However, if a civilization were to surpass nature itself, developing technologies powerful enough to induce phenomena that never occur naturally, such as unprecedented collisions of particles, then such unused, hidden code might begin to surface. Much like unused data in the game files that never appear in gameplay, but can still be uncovered through data mining. Moreover, if Predecessor possesses the power to manipulate the mathematics of this universe, the range of possible places where a message could be embedded expands greatly. It could be encoded into the infinite decimal expansions of transcendental numbers such as pi or e, or embedded as solutions to certain equations. It could appear anywhere. Among these possibilities, prime numbers are especially strong candidates for use as a medium. If some fundamental pattern is hidden within the sequence of prime numbers, it may not affect the structure of the universe at all, nor would it alter any other part of mathematics. That makes it a safe location for inserting a message. And because prime numbers are fundamental, like physical laws, the concept of primes would likely be universal, shared by all civilizations that arise in this universe. What's more, mathematical structures like these continue indefinitely. This means they offer an unlimited storage capacity. No matter how long the message, it can be encoded. Even a message equivalent to a complete data archive of the previous universe, spanning infinite bytes, might be passed on through such means. Or perhaps it lies in a combination of the elements mentioned above, physical laws, elementary particles, and mathematical concepts. Each one on its own may be unreadable. But through their interplay, the message might emerge before us as part of a natural phenomenon. Like a compressed data file being extracted at a certain place and at a certain moment. The message, encoded into the very foundation during the creation of this universe's seed, may unfold and surface as an observable event.